Hi, Geometry. Today is Monday, March 23rd, and our next lesson is applying all the trig ratios that we have learned over the last week or so. This is the note packet that you're going to need to go through the notes with me. If you happen to be missing any kind of packets, just make sure you send me a text or an email, and I'll make sure you get what you need. So since we're applying all the trig ratios, the majority of our problems will be word problems today, and they're not as straightforward as we've been working on. So the first step in the procedure, I'm going to encourage you to draw a picture of the right triangle. Now what you're going to find this time is sometimes it's a rectangle, sometimes it's an isosceles triangle, so you might have to do additions to your drawing to make it look the way it's being described. Once you've drawn the picture, make sure you label the sides and angles with anything that is provided in the diagram. Sometimes it's a two-part problem, and sometimes they provide extra information that is used to distract you. Determine what is going to be found, and you want to assign a variable to represent that measure. If it's a side length, obviously you can use X or Y. If it's two different sides, make sure you choose two different variables. If it's an angle measure, you'll probably want to assign theta. Once you've got everything labeled, you'll want to pick the correct trig ratio. Sometimes based on all the information provided, you might have multiple options. Just make sure whatever you choose is something that can be solved. And finally, sub in everything that you're provided into your ratio and then solve for your unknown variable. For our first example, we have an isosceles triangle CAT, and they're telling us that side CA and side AT are the same and they both equal 20. So I'm going to start with my isosceles triangle. I did mark the two congruent sides. Right now you have to decide where you're going to place C, A, and T, but it looks like A is a shared point, so I'm going to place that at the top of the triangle, like this. I did label the sides both as 20, and then I did locate C and T. It also says that angles C and T are both 68 degrees, so I'm going to add that to my diagram, and that AD is an altitude. The altitude has to be drawn in by you. Remember, it's going to come straight down and hit the opposite side in a perpendicular manner, and I did label that point D. From here, we have to find the length of altitude AD to the nearest tenth. So what I'm going to do is assign my variable X for my altitude AD. And based on the information I have, the left side and the right side are exactly the same right triangle. So if you're working from acute angle 68 degrees, X is your opposite side and 20 is your hypotenuse. So that's going to tell me to use the sine ratio. So we have sine of 68 equals opposite X over hypotenuse 20. Make sure your calculator is in degree mode before you get started. We're going to cross multiply sine of 68 times 20. And this is the answer I get for the missing altitude. The directions do tell us to round it to the nearest tenth, so it's going to be approximately 18.5 units. Now they want us to find the length of CT, which is the entire base of your isosceles triangle. What I did though is I'm calling the length of DT, which is half the right triangle, Y, and I'm going to use the information on the right side of the triangle to solve for Y, and then I can double it to find the complete base. So again, I'm looking for Y. Based on my setup, Y is the adjacent side, and 20 is my hypotenuse. So I'll be using cosine for this calculation. So we have Y over 20 equals cosine of 68. Again, we're going to cross multiply. And there's our value of Y. Same thing here, we need to find the length to the nearest tenth. I'm going to multiply by 2 first to get the complete length. And there it is. And now I'm going to round it to the nearest tenth, and it so happens that it would be 15.0, We want to make sure we include the 0.0 so that we don't lose any points on our Regents exam. In example number 2, they are talking about the length of a hypotenuse. I do know I'm working with a right triangle, and they're telling me that XY does represent the hypotenuse. So let me start with my picture here. You can see XY is across from the right angle. They're also saying that the hypotenuse is 3 times the length of leg YZ. So the hypotenuse will be represented by 3x, and leg YZ is represented by x. They want us to find to the nearest degree the measure of angle y. So since that's what I'm looking for, I'm going to place theta there as my variable. Based on how I've labeled, I have x, which is my adjacent side, and 3x, which is my hypotenuse. This tells me I need to use the cosine ratio. So it'll be cosine of theta equals adjacent over hypotenuse. There is technically a coefficient in the numerator next to x. It's a 1. And then you'll notice that the x's will cancel each other. So it leaves me cosine of theta equal to 1/3. Remember, when we're looking for an angle measure, we're going to activate our inverse functions. So this will become inverse cosine of 1/3 equals theta. And you can plug it into the calculator. And I'm going to round it to the nearest whole degree, so 71 degrees. For example number 3, they're talking about the diagonals of a rectangle, each measuring 22 yards. So let me start with my rectangle diagram. I did draw in both diagonals, and I did mark one right angle. Remember, in a rectangle, the diagonals are congruent, and they'll bisect each other, but you're going to form 4 equal pieces inside that rectangle. It also tells us that when the diagonals intersect, they're forming an angle that is 110 degrees. Based on observation, I chose 110 right in the center here. Also, I know that that triangle formed with the 110 is isosceles, and my 2 missing sides are equal. With that knowledge, I know that I have 70 degrees remaining to complete the triangle, so each of those base angles then must be 35 degrees. Because I know each corner is 90, I also know that complementary to the 35 is a 55-degree angle. I filled it in just in case I needed it later as I work through the problem. They're asking us to find to the nearest integer the length and the width of the rectangle. I did call one piece x and the other piece y. What I'm going to do is work from the 35-degree angle. I'm essentially ignoring the diagonal that goes from the top left to the bottom right, and I'm treating half of the rectangle as one giant right triangle. So I have sine of 35, and it's going to be opposite, which is x, and the hypotenuse is known as 22. When I cross multiply, you can see that I get an answer of 12.6187. I am rounding it here to the nearest whole integer of 13 yards. Now I have to find the missing length, which I'm representing with y. Again, I'm going to go back to the 35-degree angle and use one giant right triangle. So y would be my adjacent side, 22 is my hypotenuse. So now I'm going to use cosine. Same thing here, we're going to cross multiply. And then I'm going to plug it into the calculator. And unrounded, it's 18.0213, but I am rounding it off to 18 yards because that's the nearest integer. This is homework 102. It says applying all ratios at the top. It should be in the packet that you received today. Make sure if you have any questions as you're going through it that you contact me. You can send me an email anytime. If you want to text me right away when you're working on it, just send me a text. Please identify yourself. Once you do that, I'll put you in as a contact, or you can call me at home. Have a great day.